Section 9.1, Basic Word Problems. One of the main reasons students struggle with word problems is because they have learned not to think carefully about the words. Example, Timmy has 25 marbles. Jimmy has 5 marbles more than Timmy. How many marbles does Jimmy have? Now this problem is not about any sort of fancy calculation. You just look at the words and think it through. If Timmy has 25 marbles and Jimmy has 5 marbles more than Timmy, how many marbles does Jimmy have? The calculation that you would do is 25 plus 5, which is 30. And so we have that Jimmy has 30 marbles. And we can check this by just thinking about the problem. Jimmy has more marbles than Timmy, and Timmy only has 25 marbles. Now the mistake that students make is that they say that the reason you should add is because you see this phrase, more than, and more than means add. Unfortunately, that's not really how the language works. Example, Timmy has 25 marbles. Timmy has 5 marbles more than Jimmy. How many marbles does Jimmy have? If you were to try to take the words more than and say that therefore this is an addition problem, you would get this problem wrong. If Timmy has 25 marbles and Timmy has 5 marbles more than Jimmy, then we need to subtract to get the number of marbles that Jimmy has. Jimmy has 20 marbles. And if you're not sure about this, plug it back into the original problem and think about it. Timmy has 25 marbles. Timmy has more marbles than Jimmy. That means the number of marbles that Jimmy has to be the smaller number. So Jimmy has 20 marbles and Timmy has 25 marbles. Makes sense. What's going on here is that the words in the problem set up a relationship. They are not an instruction on how to do the calculation. There are lots of things that students have learned that lead to these types of problems. For example, the idea here is the idea of key phrases. Key phrases give an indication of the types of relationships that are going on in a problem, but key phrases do not tell you how to solve a problem. Similarly, some students have learned that to solve a percent problem, you have to use is over of. Well, for word problems that are phrased in exactly that manner, that works just fine. But for problems that are more complicated or maybe worded slightly differently, that's just not an effective way of going about the problem, and it doesn't really demonstrate that you understand anything at all about percents. The goal of this class is to actually begin developing the process of thinking through problems carefully. In order to learn how to solve word problems, you need to train yourself to slow down and think carefully about the words. Example, the temperature today was 80 degrees. This is 3 degrees warmer than yesterday. What was the temperature yesterday? One of the important skills to develop in solving a word problem is to organize the information. In this case, we have the following information. We have today's temperature was 80, and then we have yesterday's temperature, and we know that today was 3 degrees warmer than yesterday. And so we need to figure out how we get from today's temperature to yesterday's temperature, knowing that today was warmer than yesterday. Well, if today was warmer than yesterday, then yesterday the temperature was smaller, and so we'd have to subtract 3. 80 minus 3 is 77. The temperature was 77 degrees. Example, the temperature yesterday was 80 degrees. This is 3 degrees cooler than today. What was the temperature today? So again, we need to organize the information. Yesterday, today, and then we know that yesterday was 80 degrees. Yesterday's temperature was cooler than today's temperature. That means today's temperature went up by 3 degrees. +80 plus 3 is 83. The temperature today was 83 degrees. Example, a box can hold 12 eggs. If there are 144 eggs, how many boxes do you need to hold all the eggs? So in this problem, we start with 144 eggs. I'm not going to draw them all out, but we can imagine having this long line of eggs. And then we know that a box holds 12 eggs. So that means if I have a box, I can stick 12 eggs into that box. And the question is, how many boxes do we have? Well, what we're doing is we're taking a number of items and we're breaking them up into groups. That leads us to the concept of division. 144 divided by 12 is 12. You need 12 boxes. Now, part of this is based on intuition, and your intuition may have led you immediately to divide. However, it's important to know why that intuition is correct. Just like with the problems with scales and balances, it's not good enough to just be able to spit out the answer, because if the numbers get changed slightly, you need to be able to understand how to do the problem. Example, a box can hold 12 eggs. If there are 24 boxes, how many eggs are there? This time you're told that you have 24 boxes. And inside each of these boxes, there are a bunch of eggs. And you're asked for the total number of eggs. So if you have all these boxes, you're trying to count the total number of eggs. Well, this is repeated addition, which is multiplication. And so you multiply the values together. 12 times 24 turns out to be 288. There are 288 eggs.